Hello, thanks for joining me today. We are going to do a section that's called complex fractions. And we're going to also review order of operations. So we're going to do a lot of algebra type stuff today. But I want to talk about this word complex. You might think the word complex means really, really difficult or complicated. But really all it means is that we have a fraction. And I'm going to draw the fraction bar here. Okay, we've got a fraction. There's a fraction bar. Let's cover up the old fraction bar with the new one. There we go. And that fraction has a numerator. Right, there's the numerator, and it has a denominator. There's the denominator. And notice that the numerator is a number, and the denominator is a number, and both those numbers are themselves fractions. That's what we mean by a complex fraction. Okay, now what do we do in this situation? We're going to put those fractions together somehow, and in order to do that, we need to have a better understanding of what this fraction bar means. And notice this is a little bit confusing because we've got three fraction bars. 1, 2, 3, because we've got a fraction and another fraction, and the two of them together are part of a big fraction. The fraction bar always means divide. That's it. A fraction bar always means division, divide by. So when you see a fraction bar, you can always think divide by, right? 2/3 is 2 divided by 3. 2/7 is 2 divided by 7. And, are you ready for this? 2/3 over 2/7 is really 2/3 divided by 2/7. That's it. That's what this means. So that's not that complicated. It's just kind of a more, maybe it's a more confusing way of writing a division problem. That's all it is. We have a division problem here, and we know how to deal with division problems in fractions. We just take the first fraction and do not change it. Then we take the operation division, divide by, and change it to multiplication. And instead of multiplying 7 2/7, we flip it over. We call that the reciprocal, and we write 7/2. All right, now we already knew this. This isn't new information. So 2/3 times 7/2, and then we can do this like a normal multiplication problem. And I'm going to skip the step where I talk about how you multiply the numerators together, 2 times 7, and the denominators together, 3 times 2, and then you reduce the fraction, because notice that they both have a 2 in them, right? The numerator is 2 times 7, the denominator is 3 times 2, so if we cross off the 2's, we're just left with 7 on top, 3 on the bottom, and that's our answer, 7/3. So 2/3 over 2/7 is equal to 7/3. That's it. Pretty simple. It's not complex. Complex just means that you've got some sort of fraction or some stuff being done with fractions in the numerator and some stuff being done with fractions in the denominator, one or the other or both. So let's do that again. Let's do it with a kind of an algebra twist to it. So we have a fraction bar in the middle, 3y over 11 over 1 over 2. So we're going to just recognize this means divide by, and it means the top, 3y over 11, divided by the bottom, the denominator, 1/2. And we can rewrite that as 3y over 11 times the reciprocal of 1/2, which is 2 over 1. And then we can multiply across. 3y times 2 is 6y. 11 times 1 is 11. And there we have it. That is complex fractions, or the hard, maybe that's like the additional hard part for complex fractions. Now the rest of the time, when we're doing complex fractions, all we're doing is we're simplifying the numerator, simplifying the denominator. before we do anything else. And so that gets us into this conversation about order of operations. And in the order of operations, this particular fraction bar, let me highlight it in red, this fraction bar right here, as all fraction bars do, this means divide by. Top divided by the bottom. But it also means parentheses or brackets over the top, the numerator, brackets over the denominator. In other words, do what's in the numerator. Whatever you can do, whatever's doable in there, do it until you end up with an answer that may or may not be a fraction. And do whatever's in the denominator, simplify it as much as you can. And then the last thing we're going to do is we're going to do the divide by. Okay, now that allows us to just take our numerator and denominator and kind of work them out separately. So for example, we can take that 3/10 plus 2, and we can work that out separately. How do we add fractions or a fraction plus a whole number? Well, we put the 2 over a 1. We multiply the numerator and the denominator by 10, so we get the denominators the same, right? The first fraction is a tenth, and the second one is a 1/. And so 1 times 10 is 10. So this becomes 3/10 plus 20/10, and that's 23/10. Now that's what the numerator is. We simplified it as much as we could. Now we can put it back in the problem. The denominator is already simplified as far as we can take it, so I'm going to rewrite the problem now. I'm just going to rewrite it here. I'm going to say that's 23/10 over 2 over 5y. And now I can think about this as a division problem. 23/10 divided by 2 over 5y equals 23/10 times 5y over 2. Now we take off our division hat, we put our multiplication hat. It's 23/10 times 5y over 2. Well, first of all, we can do a little bit of factoring here. 23 is 1 times 23. 5y is 5 times y. 10 is 2 times 5, and 2 is 2 times 1. And notice I did all that work, and the only common factors between the numerators and the denominators are these 5s. Got a 5 there, a 5 there. There's 2 2's in the denominators, 1 in each, but there's no 2's in the numerator, so we can't multiply anything there. So we're left with just 1 times 23 times y, and 2 times 2 times 1. And so we multiply all that out, and we get 23y over 4. And that is our answer to this, what looked like, okay, not going to lie, it looked complex. It is a complex fraction because it has fractions in the numerator and the denominator, but it wasn't that hard. Now, we are at a stage in life where we need to recognize a fundamental truth about algebra and about mathematics, and that is this. When you're doing complex math problems, and by complex I mean hard ones, you need to recognize that the parts of the problem are all easy. Let me show you what I mean. This whole thing was really, really ugly looking. But when you recognize that the order of operations says do the fraction bar last, and before you do that you're going to add these two numbers, well, that wasn't nearly as hard. We can add those two numbers. We can do that. And when you recognize that adding these two numbers, well, one of them is a fraction, so we could turn the other one into a fraction. And we need to think about how to get the common denominator. Well, we can do that. That's a little problem in this big, big problem. And once we get the common denominator, we can add the fractions together. And then we just had to remember that this was a piece of a big problem, and so we had to take that piece and put it back into the big problem. And once we put it back in there, we see that this complex fraction is still technically a complex fraction, but it's not nearly as hard as it was. It's just a division problem. And once we see it as a division problem, we can easily turn it into a multiplication problem. And we can do that multiplication problem by canceling out factors, and we get our answer. Now, there's probably like 5 steps here that were 5 different lessons from previous chapters we've talked about. But once you break this big complex problem down into little steps, it turns out that it's not that hard, and none of the little steps are hard, and the whole thing then is not that hard as long as you do it in the right order. All of math is like that. Even really, really complicated calculus questions can usually be broken down into simple little steps that anyone can do. And so even if you say, I'm no good at math, I don't understand fractions, it's probably because you're not breaking the problem down into small enough steps. And if you break it into small steps, you can do it. All right. Let's go through a couple more examples, and then it will be your turn to try this. We're going to take a shift here and talk about order of operations. That's a big deal for us in this lesson, order of operations. So when we see a problem like this, there's a lot of operations going on here. There's a subtraction, there is an exponent, and then there's another exponent. And we remember that PEMDAS, the E stands for exponents. We always do our exponents first, as long as there's nothing inside parentheses telling us to do that first. So we're going to do the exponents first. We're going to take the first one, 3 squared, and we're going to write that as 3 times 3 is 9, minus 1/2 squared, and that's 1/2 times 1/2. Now, I like to write this down off the side. 1/2 times 1/2 is 1 times 1 is 1, and 2 times 2 is 4. It's 1/4. So 1/2 squared is 1/4. So first step, order of operations, do the exponents. Second step is to do the, well, there's only one operation left. It's subtraction. Let's do subtraction. We have to think about how we're going to do the subtraction. We have 9 minus 1/4. One of those is a fraction, one is not. Let's turn the one that's not a fraction into a fraction. So we'll just put it over 1. And now we need to get those denominators to be the same. Well, 1 is a 4, 1's a 1. If I multiply the 1 times 4, then it becomes a 4. And if I'm going to do that to the denominator, I have to do it to the numerator. So this becomes 36 fourths minus 1/4. And 36 fourths minus 1/4 is 35 fourths. And notice that 35 fourths is just a tiny bit smaller than 9, right? 36 divided by 4 is 9. We just took away 1/4, and so we're 1/4 away from 9, which is a little bit less than 9. But right now, we really don't care about representing this as a decimal or a mixed number. We're just happy to get it into improper fraction form so we can use it later on in algebra. Alrighty, let's do the next one. Parenthesis 2/5 plus 3/5, parenthesis, close parenthesis, open parenthesis, 1/3 minus 6/10, close parenthesis. Notice that I said the word parenthesis a whole bunch of times. That is an operation. The parenthesis says do what's inside first, which is plus, and this parenthesis says do what's inside first, which is a minus, a subtraction problem. And then the two parentheses together say, no, nothing in the gap there, that must mean multiplication. So we have three operations: addition, subtraction, multiplication. Order of operations is broken by the parentheses, so that we do the addition and the subtraction first. Well, we can do the addition easy. What's 2/5 plus 3/5? Not 2/5 plus 3/5 is just, denominators are exactly the same, so we can add or subtract the numerators. 2 plus 3 is 5. 5/5. I'm going to keep that in parentheses. And now I'm going to deal with the second parenthesis, and I'm going to have to do that one with several steps. 1/3 minus 6/10. 3 and 10 have nothing in common. It's nothing times 3 that equals 10, nothing times 10 that equals 3. So we're going to multiply them by each other. So times 10 to the 3 and the 1 times 3 to the 6 and the 10. And we're left, this becomes 10/30, which is 1/3, minus 18/30, which is 6/10. And so order of operations, we still have a multiplication, we still have a subtraction, but those parentheses are telling us do the subtraction first, and now we can. So this becomes 5/5 times 10/30 minus 18/30 is 10. Denominators are the same, exactly the same. So 10 minus 18 is -8. Okay, now I kept writing 5/5, but you were probably saying to yourself, well, 5/5 is just 1. And that's true, that's 1. And -8/30 that, remember, whenever we add or subtract a fraction, we have to think about, can that be reduced? And it can. That becomes, oops, I wrote an equal sign, didn't mean to. That becomes -4/15. Of course, 1 times -4/15 is just -4/15. And there we have it. Okay, so it looked really bad, and it was a little bad, but it wasn't that bad. You can do this. Okay, for the last few examples, we are going to do problems that involve this word evaluate. And this is just an algebra idea where I have an expression, an algebraic expression that includes variables, x and y in this case, and then I tell you what the variables stand for. And so all you have to do is replace the variable in the expression with what it stands for, and then you simplify the expression, simplify whatever it is that you've got there. Now, of course, this chapter being what it is, we are going to have our variables stand for fractions, and that will be the big deal here. So let's first rewrite our expression, 2 times x. That 2x means 2 times x, and x is -1/3. Minus y, and I'm going to put a parenthesis, just in case y was negative or something, and y is 3/5. So now we can simplify this. Let's see. 2 times -1/3, well, we put the 2 over 1 and we multiply across. That's -2/3. And then minus 3/5, we'll say minus 3/5. And now this is a subtraction problem. We have two fractions. The denominators are not the same, and they don't have anything in common either. So we're just going to multiply them by each other. Times 5, times 5, times 3, times 3. And that gives us -10 over 15 minus 9 over 15. The denominators are exactly the same, so we can add the numerators or subtract. Negative 10 minus 9. What is negative 10 minus 9? Well, negative 10 minus 9 is negative 19. So now we have to remember our integer addition rules and keep the denominator exactly the same. So once again, we're seeing that these problems are not difficult, but they do involve using all the skills that we've learned so far. Maybe not all of them, but a lot of them. So we just have to be very careful, go very slowly, do step by step, order of operations, each thing in its place, and you'll get the right answer. Notice that it's really helpful if you give yourself lots of white space on your paper, so don't try to squeeze these answers in the book. And notice that it's really easy to make mistakes if you have sloppy handwriting, like sometimes I do. So be sure to write very neat and be prepared to try it again, do it over again if you find that you've lost track of what you're doing, you're messing up. Okay. I'm going to erase this answer because I am wanting to show you the next one cleanly. Evaluate x over z. Well, we're going to take and write a big fraction bar here. And then on top, we're going to write what x is, which is negative 1/3. On the bottom, we'll write what z is, which is 5/6. Now we know that this is a division problem. Negative 1/3 divided by 5/6, which is the same as negative 1/3 times 6/5. We could write the answer down right now, but notice that 6 is made up of 2 times 3. If I recognize that there's a 3 in the numerator and denominator, I save myself a little bit of time. Negative 1 times 2 is negative 2, and there's only a 5 in the denominator. Negative 2/5 is the reduced answer to this question. Okay, let's do one more, and we are going to have a problem here because I have written down what x and y stand for. It's the top of the page, but you can't see it right now. So you're just going to have to take my word for it. Always a dangerous thing to do. So I'm going to rewrite this. 1 plus, now because I'm adding, I'm not too worried about my x, but I need to be careful here, so I'm going to put it in a bracket. X is negative 1/3. Okay, and then I put in this parenthesis, and now I'm going to put in that parenthesis, and now 1 plus, and I'll do another bracket here just in case. Y is 3/5. And notice that that bracket was useful for me because here, right here, it kept that plus sign and the negative sign separate from each other. I can rewrite this as 1 minus 1/3 times 1 plus 3/5. Now, I'm going to change those 1's into fractions, 1 over 1. And then notice that I need to get my denominators the same, so I'm going to multiply the denominator, the first one by 3, and the numerator by 3. So we have 3 over 3 minus 1 over 3. And the second fraction we're needing fifths. We'll multiply top and bottom by 5, so we get 5 over 5 plus 3 over 5. And 3/3 minus 1/3 is 2/3. And 5/5 plus 3/5 is 8/5. And now we take off our addition hat and we put on our multiplication hat. 2/3 times 8/5, we multiply 2 times 8 is 16. 3 times 5 is 15. And 16/15 is our final answer. Okay, let's do one more problem here. Remember that x is negative 1/3, and we're going to square that, minus y is 3/5, and z is 5/6. We're going to think about order of operation for just a minute. Remember, we're going to do the exponent first. We have a subtraction problem there, but before we do that, we're going to do this multiplication problem. So the order is going to be 1, 2, 3. Well, negative 1/3 squared is negative 1/3 times negative 1/3, or positive 1/9. Minus, now because that minus sign is separating the exponent fraction and the multiplication of fractions, I can go ahead and do the multiplication here. Let's see, yeah, let's do that. So notice that 6 is 3 times 2, so if I cross off the 3's and the 5's, I'm left with 1/2. That's going to save me a lot of trouble here, because now trying to get my common denominator is not going to be 30, and one denominator is not going to be 30. So I can figure out the common denominator between 2 and 9 fairly easily. I think it's going to be 9 times 2, which is 18. So I'm going to do times 2, times 2, times 9, and times 9. That gives me 2/18 minus 9/18. 2/18 minus 9/18 is negative 7/18. And then that fraction cannot be reduced. 7 is 1 times 7, 18 is 2 times 9. So no common factors, and we are done. Well, thank you very much. This is a long video, lots of examples. I hope this is helpful. Please take your time. Recognize that most of the problem here is going to be just figuring out how to break these into small bites. And each small bite you can chew up easy, as long as you can identify what you're doing at each stage of the problem. Thanks for watching. Have a great day.